In fact, NASA is preparing to release its highest resolution images yet of this object as it makes its close pass by Mars on October 3rd. What started as whispers inside research circles has now turned into an official development. NASA has finally broken its silence. They quietly posted a live stream announcement scheduled for 12 p.m. Pacific time on November 19th, confirming that brand new images of 3I Atlas will be revealed to the world. And based on everything you've just heard, it's clear why this announcement is already sending shockwaves across the scientific community. Because if even a fraction of what's been observed holds up under scrutiny, this could become the biggest story on Earth, and possibly the biggest story in the entire universe. That's why SETI's sudden post caught everyone completely off guard. Out of nowhere, they told their followers that NASA would be unveiling fresh spacecraft and telescope imagery of 3I Atlas on November 19th. Data coming not from one observatory, but from multiple spacecraft and high-power telescopes scattered throughout the solar system. NASA almost never holds a dedicated event for a single comet, and SETI almost never spotlights one unless the incoming data is exceptional. The timing alone set off alarms. Why now? And why this object? Stay with this story because what happens next will genuinely reshape what you think you know. If the mystery of 3I Atlas fascinates you and you want to keep exploring these cosmic revelations, hit that like button and let the universe know you're paying attention. And leave a comment telling me where in the world you're watching from. I want to see the global audience witnessing this moment right alongside me. At the same time all this was happening, a new wave of images of 3I Atlas suddenly began to spread online, pulling astronomers and hobbyists into the conversation instantly. These sharp, high-contrast frames showed a luminous cloud with strange internal structures and color patterns that looked nothing like any ordinary comet ever studied. 3I Atlas looked larger than nearby stars, brighter, more vivid, and most unsettling of all, its form shifted slightly from frame to frame. Its tail wasn't straight, it was lopsided, almost unstable, implying that something inside the dust cloud was twisting or spiraling. Even without knowing the origin of the footage, one thing was obvious. This was not behaving like a typical comet. The buzz only intensified when Avi Loeb published even more detailed images in a long post. These showed jets firing in multiple directions, narrow columns of gas shooting outward, and sharp filament-like structures extending into the darkness. These weren't CGI renders or enhanced concept art, these were direct observations. It made 3I Atlas look less like a melting ice fragment and more like a complex, layered system, almost mechanical in its behavior. The combination of SETI's enhanced signal detection, the mysterious NASA announcement, and these increasingly unexplainable images has created a level of speculation we haven't seen in years. Because 3I Atlas is dismantling every standard model of comet physics. Its shape, its movement, its jets, its rotation, its internal structure. With every new observation, the question becomes harder to ignore. What exactly is happening out there in interstellar space? NASA and other agencies have continued to avoid answering any direct questions about 3I Atlas's bizarre behavior, but the information vacuum is being filled rapidly by a massive network of independent astronomers across the United States. Free from bureaucracy and publication delays, they observe the object in real time, uploading their frames the moment they are captured. Their footage has now become the single most accurate and up-to-date source of data about 3I Atlas as it changes night after night. These amateur images show structures that, if left to official channels alone, the public would likely never see for weeks or months. And among this torrent of new data, one particular sequence of images has shaken experts and fueled endless debate. A rapid set of exposures appears to show 3I Atlas spinning far faster than expected, even shifting its axis in just a few minutes. The moment this hit the forums, scientists jumped in to explain the anomaly. Some suggested that asymmetric outgassing jets could push the nucleus into unusual rotation, but many analysts weren't convinced. The motion looked too smooth, too coordinated, almost like something was adjusting its orientation deliberately instead of randomly venting dust and ice. That idea ignited a storm of speculation across American social media, where distrust in government transparency is already sky-high. If amateur astronomers captured this strange rotation, then NASA, with instruments hundreds of times more powerful, must have known long before today. So why stay silent? Why wait until November 19th? Many commentators went further, pointing to the unannounced closed-door meetings that recently took place between Congress and NASA, meetings that still have no public explanation. Major U.S. media outlets have begun comparing this moment to the 2017 Oumuamua situation, but with far more tension, far more uncertainty, and far more unanswered questions. While professional scientists continue to urge caution, the rapid rotation sequence has planted a new and unsettling question in the public mind. Is 3I Atlas truly a natural comet, or is something guiding its trajectory through space? Until NASA speaks, the independent astronomical community remains the most transparent and reliable source of data, something almost unheard of in the history of U.S. space research. The observer who recorded these remarkable frames later explained exactly how he did it, and astonishingly, the entire setup was nothing more than a standard consumer-grade telescope paired with a simple RGB camera. No specialized filters, no advanced equipment. He even removed the built-in IR UV filter just to capture the natural color gradients within the dust cloud, trying to represent 3I Atlas as faithfully as possible. Dozens of long-exposure frames were carefully stacked to reduce noise, and only the smallest amount of sharpening was applied, just enough to enhance the structure without introducing artificial edges. It was the kind of precision you'd expect from a controlled laboratory environment, not from a backyard setup under the night sky. But the real shock came from the sequence of images taken just minutes apart. 3I Atlas isn't behaving like a drifting, passive comet. Its form seems to stretch, twist, and subtly contort while streams of dust bend and flare in new directions. These aren't random fluctuations. The brightness pulses through the surrounding cloud in repeating patterns, far too rhythmic to dismiss as coincidence. From this observer's vantage point, the pattern is unmistakable. 3I Atlas is rotating fast, likely counterclockwise, and with a precision that defies typical comet behavior. The speed at which its shape altered in those brief minutes instantly ignited a new wave of speculation among American astronomers. Was this the result of uneven outgassing jets, or were they seeing the faint traces of a control system at work? Some threads online went even further, wondering aloud if 3I Atlas might be self-correcting its orientation, a trait never seen in natural comet nuclei. While many traditional researchers remain wary of jumping to conclusions, the images themselves provide something NASA has conspicuously avoided offering: visual evidence that 3I Atlas is acting with unusual organization, almost intention. With the U.S. Space Agency still silent, it's these quiet, anonymous observers who are now raising the questions that professionals can no longer comfortably ignore. If 3I Atlas truly is spinning rapidly enough to reshape itself within minutes, the implications are enormous. Most cometary nuclei take many hours, sometimes tens of hours, to complete a single rotation. Even the fastest known spinners rarely show noticeable shape changes in such a short time frame. But if 3I Atlas is spinning at this astonishing rate, the jets emerging from its surface could be sweeping through space like rotating beams, carving razor-thin, sharply directed, constantly shifting tails, the very formations seen in the latest images. This extreme rotation could also create intense internal pressures, pushing the outgassing rates into chaotic swings and even raising the possibility of structural fragmentation. Yet, what looks chaotic to the eye might actually be the predictable consequence of a body spinning violently under the harsh furnace of the sun. The independent observer who captured the sequence admitted the limitations of his setup and the danger of overinterpreting amateur data. But even with that caution, the consistency of the frames, captured mere minutes apart, made his conclusions difficult for anyone to dismiss. And the moment this footage went public, many American astronomers began asking the same question. Is 3I Atlas simply a rapidly spinning comet, or is it an object following principles we haven't yet discovered? These observers weren't the only ones adding fuel to the mystery. Around this time, Avi Loeb published a short but striking analysis, compiling some of the clearest and most detailed images of 3I Atlas available to the public. Loeb avoided sensational claims. Instead, he let the images speak.
And what they showed was unmistakable. 3i Atlas doesn't resemble the soft, diffuse smear of gas seen in standard comet photos. It looks like a structured object, bright and intricate, with jets erupting from multiple regions of its surface. It's as if the jets originate from designated vents rather than an unstructured, randomly heated surface. Most striking of all is the reverse tail slicing across the frame and pointing directly toward the sun, a phenomenon so rare that it challenges nearly every accepted comet model. Meanwhile, the main tail of 3i Atlas stretches into a narrow, highly collimated column of gas, far more coherent and focused than the broad scattered tails of known comets. These features don't just appear once and vanish. Across multiple exposures taken days apart, the same bizarre structures consistently return, suggesting that 3i Atlas maintains its form despite intense radiation or rebuilds it rapidly after every disturbance. For the American public accustomed to simple, fuzzy textbook images of comets, Loeb's compilation hit like a revelation. The beauty of the object was undeniable, but so was the unsettling implication. Is 3i Atlas merely an unusually violent comet? Or is it a complex system operating on principles we barely understand? Loeb's choice to refrain from speculation made the images even more provocative. What the public saw wasn't a chaotic object, but a comet that appeared to be organized, structured, active in a deliberate pattern as if driven by deeper internal mechanics. With NASA keeping quiet and public skepticism growing, these images have become impossible to ignore. The 3i Atlas story now sits at the intersection of curiosity, scientific tension, and outright mystery. Is this just a comet going through extreme behavior, or is it something more, something with mechanisms in physics beyond our models? Every image Loeb released pushes that question further into the spotlight. Meanwhile, Saudi's focus on NASA's upcoming announcement stands sharply against their silence toward the independent community. They haven't addressed the spin rate. They haven't discussed the multi-directional jets. They've ignored the rapid morphological changes. And that silence is becoming louder by the day.
NASA, as an institution, is famously cautious, slow to speculate, careful with phrasing, and almost never willing to sensationalize unverified data. That's why their decision to broadcast a live announcement to millions was more than a routine update. It was a signal, a scientific endorsement, an indirect but unmistakable acknowledgement that 3i Atlas is no ordinary visitor drifting through the solar system. Interstellar objects are incredibly rare. Every flicker, every texture, every shifting feature is scientifically priceless, whether it behaves predictably or in ways no one can explain. And the fact that SETI chose to actively promote NASA's upcoming announcement suggests something else entirely. They believe what is coming is not routine. Even without mentioning the bizarre ground-based observations, SETI's decision to direct public attention toward the event carried the weight of a quiet warning, an implication that the images and data about to be revealed may fundamentally reshape how the world sees 3i Atlas. In this charged atmosphere, independent observers continue capturing strange, unexplained features NASA has yet to address, and SETI's silence hasn't eased skepticism. If anything, it has amplified the sense that NASA's release is not merely another batch of comet imagery. It may be the missing piece of a much larger story that has been unfolding piece by piece from the moment this interstellar object entered our system. All focus now converges on NASA's November 19 event, and each new observation only heightens anticipation. NASA has confirmed that several missions across multiple instruments, wavelengths, and orbital positions have recorded 3i Atlas. This means the object has been observed from angles and energies that ground telescopes could never hope to match. It's no longer a random series of lucky snapshots. It's a coordinated data set from space. If the suspected extreme rotation is real, NASA's instruments will reveal it. If the sweeping arcs of the jets are genuine, spacecraft cameras will capture them with clarity far beyond what Earth's atmosphere allows. If the narrow, laser-like tail is truly the product of rapid spin interacting with the solar wind, multi-mission analysis will expose the physics behind it. Right now, the world sees 3i Atlas
only through the blurred window of weather, atmospheric distortion, and chance. But that will soon change. What's coming is a view from above the noise, clean, sharp, and definitive. And when NASA publishes this data, the debate will not be whether 3I Atlas is unusual. The question will shift to how far it pushes the boundaries of current science. Speculation about the object's nature remains grounded, at least for now. The most widely discussed scientific theory is that its rapid spin could be driven by asymmetric jets, acting like natural thrusters, gradually accelerating or redirecting the nucleus. Another possibility is that 3I Atlas is tumbling, with sunlight heating its uneven surfaces and inducing unpredictable rotations. Interstellar material may also behave differently. Objects formed around different stars, in foreign pressure environments, under alien radiation conditions, could easily show characteristics unfamiliar to scientists studying local comets. None of these explanations require fantastical assumptions. They simply require an openness to the idea that 3I Atlas does not follow the patterns we expect from comets born within our solar system. This difference, this alien origin, is exactly what makes the object so captivating. Every feature can still fit within science, but each one also carries a whisper of deeper, unknown mechanics. Yet the visual evidence remains undeniably odd. Multiple jets firing in various directions as though triggered by independent systems, a reverse tail holding steady in defiance of solar pressure, and a thin, needle-like plume stretching into space with uncanny stability. Nothing here proves anything beyond natural processes, but collectively, these patterns imply a sophistication that demands better data. Data only spacecraft can provide. And this is where NASA, SETI, and researchers like Avi Loeb form a strange scientific triangle. NASA stands quietly, cautious as ever, waiting for the data to speak before drawing conclusions. Loeb highlights the anomalies, urging scientists not to ignore what they can plainly see simply because it breaks old models. SETI maintains controlled curiosity, avoiding theories, but nudging the public toward focused observation instead of panic or fantasy. Together, these approaches have reframed 3I Atlas, not as an enigma, but as a scientific opportunity, one of the rarest chances in history to test physical theories, probe interstellar material, and observe behavior scarcely witnessed in cosmic time. As the world counts down the final nights before November 19, independent astronomers continue capturing new frames. Each one adds another fragment to the growing puzzle. 3I Atlas is not acting like a dormant traveler, simply passing through. It is flaring, shifting, twisting, its shape mutating, maybe even spinning far faster than the models predict possible. The real question now is not whether 3I Atlas is unusual, it's what those unusual features imply. Is the rapid rotation genuine? Are the jets coordinated in some way? Or is the comet simply displaying physics that no telescope has clearly captured before? All theories now hinge on the next wave of data. When NASA finally releases its imagery, it may confirm the amateur's claims. It may debunk them. Or, perhaps most unsettling of all for those seeking certainty, it may reveal entirely new features no one has even imagined yet. Until then, the sky waits, silent, except for the occasional shutter click from those who refuse to look away from this interstellar visitor, an object challenging every assumption we believed was solid.